digit numbers start. The 3-digit numbers starts from 100 and ends with 999. So the first digit of or one's digit, not the 100th digit of first place, which is 100 digits of 3-digit number, has the digit 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 places for the first place, hundredths. You cannot have 0 on the hundredths place. Then for second place, which is 10th place, you have 0, 1, 2, 3, 4, 5, 6, 8, 9, 10 of them. Then for the third place, which is ones, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10. So 9 times 10 times 10 is 900. So we have 900 3-digit numbers. Now, what is the probability that we select one a 3-digit number? So 1 over 900. So probability of selecting a 3-digit number is 1 over 900. Now, what is expectation? X, which is the price in this case, times probability of X. Your price is 500 times probability of selecting a 3-digit number is 1 over 900. So 500 times 1 over 900. You get 500 over 900. You can delete the zeros. You get 5 over 9. Then change it to decimal. You get 0.5556, which is basically 55 cents. Okay, 55 cents. Any question about the first part?
It doesn't match the answer in the book. I think they used 1,000 numbers.
1,000 of them?
They used 10 digits for each one. So
they use 10.
They include 0 as a leading placeholder.
Okay.
So if it's, I think that's what they did.
Okay. So that's not correct, because when they say 10-digit number, we should not include the 0.
The 3-digit number.
Yeah. So this is the way I want.
Okay. Okay.
Sorry, for the 3-digit number, how did you get like first place, second place, third place, like 9, 10, and 10?
Okay. Like for hundreds. So let's look at, for instance, 245. Okay, that's a 3-digit number, okay? For the 2, the hundreds, you can have 1. You cannot have 0 digit. Because if you have a 0 digit for 100, you get 2-digit number, correct?
Yes.
So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 choices for hundredths place. 9.
Okay, got you.
Then for tenths place, you can have 0 through 9, which is 10 numbers. For ones place, you can have 0 through 9, so 10 digits. Okay, understand?
Okay.
Good. Now, in the same daily lottery, if a person boxes a number, she will win $80. Find the expectation if the number 123 is played for $1 and boxed. What do we mean boxing? So you have numbers 1, 2, 3, and if you get any combination of 1, 2, 3, you win $80. So how many combinations do we have? Here, I have, you can have 1, 2, 3, then I keep 1 fixed, then I write 3, 2, okay? Then 2, 1, 3, keep the 2 fixed, then you get 2, 3, 1. Then we have 3, 1, 2, 3, 1, 2, keep 3 fixed, then you get 3, 2, 1. So there are 6 ways to box 1, 2, 3 to get any combinations of 1, 2, 3. There are 6 ways. Any question? So what is the probability that the number 1, 2, 3 is boxed? 6 out of 900. Why 900? Because there are 900 three-digit numbers. Okay. Now, expectation is sum of X, which is price times probability of X. X is 80 times 6 over 900. You get 480 over 900. I reduce it to 8 over 15, then 0.5333, which is 53 cents. Question? No more question on problem number 9, section 5.2?
Not
Okay.
seeing any right now.
What is it?
I'm not seeing any right now.
What do you mean? I did
I'm
not
not
stop.
seeing any in the chat.
Oh, I see. Okay,
I
let me
think-
look at the stop sharing and look at another questions that Sean, what you told me. You told me problem number 15, section 5.3.
Right. More than one person asked about this.
Okay. This is the section on binomial distribution of graduating high school seniors. 14% said that their generation will be remembered for their social concerns. If 17 graduate seniors are selected at random, which is our N, 7 is our N, find the probability that either 2 or 3 will agree with this statement. So success is this graduate high school are remembered for their social concern. That's success. Failure is the opposite of that, are not remembered for their social success. So P is 14%, 0.14. Q is 1 minus 0.14, which is 0.86. Okay. Find the probability either 2 or 3. So we are finding probability of X equal to 2 or 3. The probability of X equal to 2 or 3. Hold on a second. Let me see what's going on. I'm delinging. Okay. Shauna,
Yes, ma'am.
I don't know. Can you send a message to Jason Echiveste?
Okay.
I think he's
Let me find him.
he's trying to come to the meeting and
Is he in the meet? Oh, but he's not in this meeting.
but he's trying to get to the meeting.
Oh, from okay, let me pull the link down. Also, just to jot in your notes, we have a question in the chat asking you to go over at least
Yeah, I
our
will. Let me
binomial.
finish
Can you
this. Yeah.
please go over that?
Okay. So find the probability of either 2 or 3. So probability of exactly 2 or probability of exactly 3. So when you have exactly 2 or exactly 3, you use the formula, combination of n choose a, probability to the power of a, q to the power of n minus a. So I'm writing this formula twice, 1 for 2, 1 for 3, and add them. So combination of n is 7, we are choosing 2, 0.14, probability of success to the power of 2, Q, which is 0.86 to the power of 7 minus 2. Plus, now I write the probability for 3, combination of 7 choose 3, 0.14 to the power of 3, 0.86 to the power of 7 minus 3. So I clean that up. I get combination of 7 choose 2, 0.14 to the power of 2, 0.86 to the power of 5. Did the same thing with the combination for 3. Combination of 7 choose 3, 0.14 to the power of 3, 0.86 to the power of 4. Let me show you how to find this one of the combination with the calculator. So we had 7 math. We go to probability, choose item 3, 2, 0.14 times 0.14 to the power of, oh, sorry, actually delete that. To the power of 2. I leave the power by pressing the right arrow key times 0.86 to the power of 7 minus 2 is 5. I get the 0.1936. 0.1936. That's what I have. Oops. Oh, 0.1936. Then I don't know, please ignore what you see here. I don't know what that is. Ignore 0.1768. Then I found the combination of 7 choose 3. The second one, I end up with 0.0525. I add them up. I get 0.2461, 24.61%. Ignore this. Any question about this problem? 15? Okay, let me stop sharing.
For that one, when we see it like on a quiz or an exam, when you say X, like 2 or 3, we would use binomial PDF all the time, like exactly.
Yes, you can use, because since it says exactly, you use binomial PDF twice. Or
And then
you use the formula twice. You either, for exactly, you have 2 choices, formula or binomial PDF. 1 for 2, 1 for 3. Then add the result. Either way, add the result.
Yeah. When we're using binomial PDF, it will be just for or and exactly?
Yes. Yes.
Okay. Okay, sounds good.
Or means you are adding. Like, do you remember in chapter 4, when we started section 4.1, every time you have or, you add up?
Okay.
Or means add. Exactly here, you use a formula or binomial PDF.
Okay, sounds good. Thank you.
Shauna, let me look at the 6.1 question, then I go and look at the at most. Can you find an example of at most? Any of the
At least,
problem?
at least,
It's
sure.
At least, then I...
Sure, and I sent the message to Jason, but I don't see him yet.
Okay. Because he's just, I'm receiving his email that he's trying to get to the meeting and he cannot. I don't know which one he's... Okay. 6.1. I didn't have the opportunity in class to... do you remember in 6.1, we use normal CDF to find the area under bell curve? Then I did some example of finding the area under bell curve, but there are sometimes we give you the area under the curve and we ask you to find the Z value. Like in this case, example question, it says find the Z value that correspond to the given area. Okay, so I gave you the area from 0 to the Z, the area of this orange region, and I want you to give me the area, the Z value. What is the Z? Now, since z is on the left side of 0, z has to be a negative number. Okay, so that's a 1. Now, what is the formula that we use to find if we have the area under the curve? Z, if we have the area under the curve, we use the formula z equal to inverse norm. There is only one parameter. What is the parameter? Area from negative infinity to the z line. Area from negative infinity to the z line. Okay. I have given you the area to the right of z line, but I need the area to the left of z line because I said the area from negative infinity to the z line. But I have given you part of the area to the right of the z line. In section 6.1, one of the property of area under the bell curve is that the area under the whole curve is 100%. So if I shade the area under the whole curve, the whole bell-shaped curve is 100%. 100% is the same as 1 if you change it to decimal. If you draw the line where 0 is, the area to the right of 0, all the way to the right, is half of 1, which is 0.5, 50%. The area to the left of the 0 line is 50%, also half. Okay? So the line 0 divide the bell curve into 2 equal parts. The area on the right side is 50%, 0.5. The area to the left is 50%, 0.5. So the area of the orange region and the area of the white region from negative infinity to z has to add up to 0.5. Okay? So area of the white plus the area of the yellow is 0.5. So area of the white plus area of the yellow is 0.5. So the area of the white is equal to, if I think of algebra, I can say, okay, let me, hold on a second. Let me open something. Can I stop sharing for a second? 2161. Okay, I'm saying that let me share this. Area of white region plus area of yellow region is equal to 50%, 0.5, correct? Now, if I isolate area of the white, how do I isolate the area of the white? I subtract area of the yellow from both sides. So area of the white equal to 0.5 minus area yellow. Okay? Which is equal to 0.5 minus, and that is 0.4175, correct? And that is equal to 0.0825.
Are you using 0.5 since it's the closest to 0.41?
No. The reason that I'm using 0.5 is that look at the zero line, okay? The area under the whole bell curve is 1, which is the same as 100%. Okay? The area of the left region, the area of the whole left region is 0.5. The area of the whole right region is 0.5. Clear?
Okay.
Okay. Can you, Sean, remove
Sure.
this drawing?
This, that's this half. This white region is this region on the left. That
Yeah,
she's-
I'm talking about, can you remove?
Yeah, hold
So-
on. I'll remove
Am I
it.
assuming it's like 0.5 here and 0.5 there, and in total it's 1, right?
Yes.
The area to the
But-
left of zero line, the whole area to the left of zero line is 0.5 on the right side, and the area on the left of zero line, the whole thing is 0.5.
Okay,
So,
thank you.
because the area under the whole thing is what? So, area of this little white region that we are looking at, because we want Z norm is area from negative infinity to the Z line. So, area of this white plus area of this yellow is half. Now, I want to find the area of this little white. So it's 0.5 minus the area of the yellow. So 0.5 minus 0.4175 is 0.0825. So inverse norm. So where do we find inverse norm? So we go to distribution again. So we go distribution. Inverse norm is item number 3. Area was 0.0 what?
0.8
0825. Mu is 0, sigma is 1. We are looking at the left tail. Some of you may not have the left tail or center or right. Ignore that. So I end up with negative 1.3885. And when you are looking for Z and you are using inverse norm, always round your answer to 2 decimal places. So you get negative 1.389. Sorry, negative 1.39.
Mhm.
Okay. Any question? I'm going to look at more examples of
As
in-
far as your at most and at least, either 5C or 6C on section 5.3.
okay, 5.3. Let me
Yeah,
find.
either 5C or 6C. They both have at least in there.
6.2 or 3?
No, 5.3, because you asked
Oh,
for
5. I'm in chapter 5.
you were
5.3.
gonna go back, remember?
Yeah, 5.3. What number?
5 part C or 6 part C both have complements in them at least.
Okay. Okay, I'm looking at 6, problem number 6, part C. Okay. RH research found that 40% of Americans do not think that having a college education is important to succeed in business. What? If a random sample of 5 Americans is selected, find this probability. N is 5.
So you're not sharing your screen?
Oh, and I'm not sharing my screen. Oh, sorry. Okay. 40% of Americans do not think that having a college education is important to succeed in business world. Well, a sample of 5 Americans is selected. Find this probability. At least 2 people will agree with this statement. First of all, N is 5. And since we are finding probability that at least 2 agree that college education is not necessary, P would be 40%. Q, which is opposite of 40%, 1 minus 40 is 60%. At least 2 means minimum 2 and higher, okay? 2 and higher. You have to analyze the meaning of at most and at least for yourself. At least 2 means minimum 2 and higher. So we are at least 2 means 2 and higher, X greater than or equal to 2. So we are finding probability of X greater than or equal to some number 2. Every time you are using at least or at most, you have to use binomial CDF. PDF is exactly, CDF is for at most and at least. Binomial CDF is used just by itself when you have at most, like part B, at most 3, probability of X less than or equal to 3. Okay, part B says at most 3, X less than or equal to 3. I use binomial CDF by itself because that's the function of binomial CDF. It calculates all the probability starting from 0 to that number 3. Okay, binomial CDF is a function that starts with 0. But when you have at least, you have to do a little bit of switching. You have to use the complement formula. Probability of at least 2, probability of X greater than or equal to 2 is equal to 1 minus probability of at most 1. You have to use the complement. At least 2 means 2 and higher. Complement means 1 and 0. You find probability of the complement 1 and 0, which is binomial CDF of 5, which is N, 0.40 P, 1. Okay, 2 minus 1 is 1. Binomial CDF of 5, N, P, and 1. This is binomial of the complement, 0 and 1. So I find the binomial of the complement first, which is 0.3370. And I take that probability, 0.3370, take it away from 1, which gives me 0.6630. So with at least 2, you cannot use binomial CDF by itself straight. You have to say 1 minus binomial CDF of the complement. And the complement, you take away 1 from your B. Complement is binomial CDF of N, P, and 1. 1 means you have to find probability of 1 and 0, add them together, and take away the answer, this answer from 1. Question? Did I answer?
We have a question in the chat.
Uh-huh.
Somebody's asking if it's okay to not use the mathematical symbol, but to write the word instead.
Like at least?
Instead of X is greater than or equal to 2.
I think I want you to do that because with other chapters, when we get to other chapters, or maybe even next section, section 6.2 and on, we use a lot of like X less than or equal to 2, greater than or equal to 2, between 2 numbers. We use that a lot. And I want you to start using X, like get used to it. You have to know this because of the other sections. We have a lot of sections and chapters that we use variable X and with the inequality symbols. Maybe it is okay with this section, but not with other sections at all. So use it.
And if you need help with that, you can find the help in the charts that start every section of slides. Starting with, I think, chapter 5, the mathematical phrases.
Yeah.
Those are on there for you.
Yeah,
Okay?
I gave 2 slides, I think 2 pages of a slides in starting chapter 4. So in chapter 5, if you go to 5.1, you see those 2 slides. When you go to 6.1, you see those slides again, those 2 slides. And 4, those 2 slides.
Somebody's asking for number 10 from 5.3 also. That was another one that people had
Number
questions
10.
on.
Okay, let me stop sharing. Number 10. Okay. Is this a problem? Okay. In 2009, the percentage of the US population was foreign born. Okay.
Who was foreign born was 12.2.
Oh, who was foreign born was 12.2. Choose 60 US residents at random. How many would you expect to be American? Find mean variance and standard deviation for the number of foreign borns. Okay. In 2009, the percentage. So P is 12.2. That's the percentage, 12.2%. So I change 12.2% to decimal, I get 0.122. That's the P. That's the percentage of you born as foreign born. Okay.
I think that was where the confusion came in, because that's the percentage of foreign born people.
Uh-huh.
And it's asking about how many you would expect to be American born. So
Wait. Oh, how many? Yeah, American born. Yeah. First of all, probability of foreign born is 0.122. Probability of American born is 0.878. 1 minus 0.112. N is 60. Now here says how many would you expect to be American born? Okay. A percentage of American born is complement. Okay. Complement, which is 0.878. And you multiply that percentage by the 60, the sample size that they gave you, 60. You get 52.68, which is approximately 53. Since we are asking for number of people, you cannot have a decimal as your answer for number of people or item. You round up, so you get 53 approximately. So percentage of foreign born is 0.122. Percentage of American born is 1 minus 0.122, which is 0.878.
This is one of those cases where they changed the percentages. There are a few in here, but
yes,
if they're asking for American born people, you can think of P as actually being the complement of this, which is why we use Q instead.
yeah. But the second part is asking you to find mean variance and standard deviation of foreign born. So for the second part, P is 0.122, Q is 0.878. Because we are dealing with foreign-born probability, American-born probability. So mean, which is mu, is n times p. And since I'm dealing with mean for foreign-born, my p is 0.122. So you get 60 times 0.122. That's the mean. For variance, sigma squared is n times p times q, 60 times 0.122 times 0.878. You get this, 6.4270. Then if I take the square root of 6.4270, I get the standard deviation, which is 2.5352. Any question? Sometimes, if, for instance, if in this problem, I ask what is the mean, variance, and standard deviation for the number who are American-born, then for the second part, for the mean, for the P, I won't use 0.122. I use 0.878. But the variance and standard deviation would be the same because you need both P and Q, but the mean would be different. If we are finding mean of American-born, P would be 0.878. Sometimes in some of the problems, you have to see what you are finding probability or mean or variance of what. Then that would be success. Success is probability or mean of what you are finding, P. Probability of success is probability of what you are finding or mean of what you are finding, P. Okay, any other questions? If you don't have any question, I would like to go back and any question on finding area under the bell-shaped curve, which was 6.1. Oh, by the way, look, these symbols that we looked at here, word at most 5, you put the variable first, x, at most less than or equal 5, at least 7, you put x first, you put your variable x on the left side, x, at least 7, x greater than or equal 7.
We have a request to go over number 24 from 6.1, Professor.
Okay, 24.
Number 24.
6.1, 24.
Yes.
Okay, let me share my screen. Is this the one?
Looks good.
Find the z value to the left of the mean so that left of the mean. When you have a bell curve, mean is z curve or x curve. Mean is exactly in the middle. Do you see that line in the middle? That's the mean line, mu line. Find the value to the left of the mean so that 98.87% of the area under the distribution curve lies to the right of it. Okay, you have to find the z. So 98.87% of the area under the distribution curve lies to the right of it. So it means we are looking at a very, very large area to the right of z line. Okay, z line. Remember, area under the whole curve is 100%. So the z line has to be all the way to the left, like here, all the way to the left. Because area to the right of it, that blue region, is 98.87%. which is 0.9887. Okay. Now, what is the Z? Z is the formula, inverse norm of area from negative infinity to the Z line. Okay. I need to find the area of this little piece. Little piece that is white piece. Again, I say area of the white plus area of blue is equal to what? Area of this white region plus the area of the blue should be equal to what? 100%, 1. Because area under the whole curve is 1. Area on the right half is 0.5. Area on the left half is 0.5. You have to know this. The area under the whole curve is 1. Area on the right half of middle line is area to the right of middle line is 0.5. The area to the left of middle line is 0.5. Here, area of the white, this white piece, plus the area of the blue is 1. Now, if I'm looking for the area of the white, I say the area of the white equal, I'm going to subtract area blue from both sides. 1 minus area blue, which is 1 minus 0.9887. And that is equal to 0.0113. Understand? I'm using the same strategy that I use with the other problem. So Z equal to inverse norm of 1 minus 0.9887, inverse norm of 0.0013. Inverse norm is on the distribution. I think it was on item either number 3 or number 4. I show you that already. Do you want me to show it again where inverse norm is? Yes, no?
Inverse norm, yes. And somebody is also asking if you can please go over the calculator procedures for starting with number 4 for that. Can you go over one of those problems between 4
Okay,
and
let me finish one problem, then I will.
Sure.
So let me show you. Can you, Shauna, keep this number 0.113?
011, you mean
I'm looking, keep in your mind 0.0113.
0113. Okay, I can do that.
Okay, because I want to bring my calculator up. Share the screen. Okay, so you go to distribution. Inverse norm is item number 3. Area, it was
0113.
0.0113. That's for inverse norm.
Mm-hmm.
If you have tail, you put the left tail. If you don't have any tail, don't worry about it. Negative 2.2801, round to 2 decimal places, negative 2.28. Okay.
The person who asked that question is saying, thank you, they understand.
They understand now?
They understand the one you just went over, so thank you.
Okay, so I should not continue with the rest of these problems because it has...
But you can do, if you could do an example from number 4 through 13.
Okay,
Somebody wants to go over those calculator procedures are, I think, the regular normal CDF.
Oh, okay.
I believe.
So 6.1.
6.1, any, the problems between 4 and 13.
Let me find my folder. What happened to my folder? 6.1 through 14.
4 through 13.
4
4
through
through 13. I think they're the ones that deal with the normal.
Okay.
Let me pull it up, but I believe so.
I think I
Yeah,
have 4.
they're dealing with the standard normal curves.
Okay, here is number 4. Okay. Are you seeing number 4?
Yes, we are.
Okay, when you are finding the area under the curve, you have to use a normal CDF. Normal CDF. Then for normal CDF, you have to enter 2 numbers. The left, okay, you have a green region, correct? You want to find the area of the green region. You have to enter, let's say, the left wall, which is 0 line, and the right wall, which is 0.98. Okay, so you get area is normal CDF lower Z, which is the left, if you want to say wall, then upper Z, right wall. Okay, so you go to normal CDF, you enter 0, then comma 0.98. Okay, let me share my calculator. Where is my calculator? Okay, so you go to distribution, normal CDF, not PDF. In this class, we don't use normal PDF, only binomial PDF. Normal CDF, lower was the 0. Lower was the 0. Okay, upper was 0.98. 0.98. Mu 0, sigma 1, leave it alone. That's the area, 0.3365. Left side of the green, right side of the green. You have to enter the left side of the green region, then right side of the green region. Question? That's the area. Okay, let me look at another problem.
I put a couple of reminders in the chat there for the difference between normal CDF and inverse norm. So
Normal CDF gives you the area under the curve. Inverse give you the location of your Z. Then I look at 4. Let me look at 6. You want to find the area to the right of Z equal to 0.29. On your quiz and on your exam and homework, I want you to draw the shaded region. 0.29, first of all, you draw your bell curve, draw the 0 line. 0 line, which is this black line, exactly in the middle. And that is 0 line, 0 line. 0.29 is to the right of 0. So that's why it's close to 0. Suppose this is 0, and that's 1, that's 2, 3, and so forth. 0.29 is close to 0, but on the right side of it. So that's 0.29 line. I have to shade the right side of it, the right side. Here it is, the right side. Okay. I want to find the area of the right side. I use normal CDF. You have to enter 2 numbers. The left side of the shaded region or left wall, which is 0.29, and the right side. The right side is going all the way to the right side. and that's positive infinity. All the way to the right, positive infinity. In this class, positive infinity represented with E99. So let me show you the calculator. So you go to distribution, you find, oh, sorry, I don't know where I went. Distribution.
Like in this, yeah, you go.
Normal CDF. Left side was 0.29. Left side of the shaded region, 0.29. Right side was positive infinity. We represented with E99. The E is over here. Do you see that double E? And is in blue. So you get second comma gives you 1E. It always gives you 1E. It doesn't give you double E. The reason they put double E, they didn't want you to mix up with letter E here. Double E is infinity.
86.
E, then you put 99. Leave mu 0, sigma 1 alone. That gives you the area from 0.29 to positive infinity. Question?
No,
Okay.
we've just got somebody else trying to access the meeting who can't get in. So let me see if I can Canvas message them.
Okay. Let me find one with like a negative infinity. Am I still sharing something or not?
No.
Okay. I'm going to look at 7, problem number 7.
We have a problem with the link, Professor. It's saying that the link is invalid. I've gotten that from 2 people.
Maybe they are trying to come to my office hours link because I sent 2 links, one for new office hours today from 1 to 2, one for class meeting. Because if I have already 11 people use this link, so the link is valid.
Let me see if I can
Tell them that maybe they are trying, because the latest announcement that I sent is the link to new office hours. Don't use that.
Okay. Let me try, and I'll send the link from this meeting too.
Okay.
And see if that works.
Okay.
'Cause-
Number 7 is asking to find the area for standard normal distribution. The word standard means the Z curve. If we don't have the word standard, we are looking at the X curve. Okay. So you want to find the area under the curve to the left of negative Z equal to negative 1.39. Again, I draw my bell curve. I draw the line exactly in the middle. That's the 0 line. 0 line. Negative 1.3 is on the left side. This is 1, that's 2. I go beyond negative 1. So suppose this is negative 1.39. Suppose. I just put the line there, negative 1.3 line. I have to shade to the left of this line. So I go all the way to the end. Now to find the area of this green region, I have to use normal CDF. I have to enter 2 numbers. Area, I mean, the left side, always the left side of the region, then the right side of the region. Left side of the region is negative infinity. The right side is negative 1.39. Okay. So you say normal CDF, enter the left number, negative infinity, negative E99, comma, negative 1.39. Okay. Let's go to the calculator. Okay. So we go to normal, we go to distribution, normal CDF, negative infinity. Lower was negative infinity. There are two signs. This is for, do you see the symbol next to the enter key? This is negative sign. Negative, then you go to second comma gives you E, then you 99. Then you go, the right side was negative 1.39. Negative 1.39. If you put minus sign for negative sign, you get an error message. I will do that in purpose next. Let me finish this. So negative infinity, negative 1.39, negative sign. This is minus sign. Minus sign is above plus sign. Negative sign is next to enter sign. That's the area of that little green region, 0.0823. Now, let me purposely use minus sign instead of negative sign. So you go to distribution, normal CDF. Okay, let me clear this. I'm going to say minus E99. Then I go down and let me clear that one and purposely write minus 1.39. If I go down and highlight paste, press enter, I'm going to get error message. Here it is, error. It doesn't tell you, then it says go to. It says quit or go to. Go to, highlight to, then press enter. It is blinking on the sign. It's telling you this is the wrong sign. I use minus sign. I had to use negative sign. So my blinker is on negative, minus, I'm going to click negative. The negative is a smaller and higher. Then I go here and change that minus to negative. Look, minus is larger and lower. Now, if I click negative, it becomes a smaller and goes higher. Now I'm going to get the result for this symbol. So always make sure, distinguish between your negative number and minus sign. Any question, other question? So for today's quiz, you have to know chapter 5 and 6.1. For 6.1, you have to know area. You have to find the area under the curve. You have to use normal CDF. Then you enter two numbers, the left side of the region, right side of the region. Draw your bell curve. Put your numbers. Remember, 0 is in the middle of the curve. Positive numbers are on the right side, negative numbers on the left. Whatever number they give you, locate them, then shade between the two. Normal CDF of the left number, comma, the right number. For inverse norm, you have to use, remember, the area under the whole bell curve is 1. From the line in the middle, the area to the right of 0 line is half. The area to the right of 0 line is half. Sometimes we get some of the area of 2 region is half. Sometimes the area of 2 region is 1. Depends on the graph that we give you. To find the z, you have to use inverse norm. And you have to enter one number, and that's the area from negative infinity to the z line. Okay. Any other questions? Okay. I think I have explained the majority of 6.1. We still have 1 hour to go. I'm going to give you a break and start at 12:15. So I'm going to bring up 6.2 and go over 6.2 if there is no questions on 5 and 6.1 anymore. Any question?
Let's see if there's anything here. I don't see anything right now.
Okay, good.
But we had, so I think Jason and Heidi are still trying to come in, so.
Why? I don't know, because since everybody is here, not everybody, if
Yeah,
you
maybe,
guys
maybe,
could come, they should be able.
maybe after the break.
Yeah, after the break. Then yeah, I need a break too.
We'll see if they, can, we'll see if they can show up. I sent the meeting ID and the passcode as well, so if they're
Okay.
joining from a
Okay.
browser, they can
Thank you.
use that. So hopefully after the break, we'll see them.
Okay, thank you.
Mhm.
Find probability of z larger than 2.59, z greater than 2.59. It means that you have to find the area under the z curve from 2.59 to positive infinity, larger than 2.59. So 2.59 and higher. Okay. So probability of z larger than 2.59 is normal CDF of this shaded region, area of the shaded region. Normal CDF of left side of the green shaded region, 2.59, right side, positive infinity. Okay, so area under the bell-shaped curve is the same as the probability. So probability. So that's all I want to say. Like if they say find the probability of z less than 0, greater than less than 1.69, greater than 0, or probability of z between 0 and 6.69, you draw your bell-shaped curve because it's a z curve. Locate the 0 exactly in the middle, locate 1.69, shade the region between the two numbers. Probability is the area of this shaded region. Normal CDF, left side of the region 0, right side of the region 1.69, and you get 45.45%. So area that you learn in section 6.1 is the probability. Okay, now I'm going to share another 6. Oh no, that's the same. Listen. Okay, now you see 6.2.
Yes, ma'am.
Okay, so application of the normal distribution. So if you have a continuous variable and you want to find probability related to this continuous variable, you have to find the area under the variable. So we start with variable x. Then you have to figure out, you want to find probability of x less than something or greater than something or between two numbers. Do you remember somebody asked me today that do we have to use this inequality symbols? Yes. The reason is here because you want to find the probability of x, again, less than a number or larger than a number between two numbers. Okay, so we start with a variable x. We figure out what probability of variable x we want to find. Then we change variable x to variable z by z-score formula, z equal to x minus mu over sigma. Every x has its own mu and its own sigma, which will be given to you in the problem. When you use this formula, you change x to z, then z always have a mu of 0, sigma of 1, always. Okay. Finding probability of X between A and B. Okay. This procedure, we already have gone over it, because probability of X between A and B means area under the bell curve between A and B, which you already know you have to use normal CDF. So I'm going to start with example. Most tests that measure one's intelligence quotient, IQ, are designed to have a mean of 100 and a standard deviation of 15. So to measure somebody's IQ, they have to use measuring devices. So IQ is a continuous variable. Okay. It is also known that IQ are normally distributed. That purple sentence, the statement that I made purple, it is telling you that IQ is continuous because it's normal. Continuous variables are normal, bell curve, bell shape. In 1960, the psychologist Louis M. Truman set a guidelines of 140, scaled down to 136 in today's test for potential genius. A, let X be measure of one's IQ. Sketch the distribution for X. Okay. Remember, X is measure of one person's IQ. What is the mean of IQ? Mean mu is 100. Standard deviation sigma is 15. Do you remember in section 6.1, I said every X has its own mu and sigma? Here it is X, which is measure of one person's IQ. Mu is 100, sigma is 15. So we want to draw the bell-shaped curve for X. What is the probability that an individual is potential genius? Okay. So being potential genius, what is the probability that someone is potential genius? It means anybody that has IQ 136 and higher is potential genius. So you have to find probability of X larger than 136. Because if your IQ is 136 or higher, you are considered as potential genius. Okay, I have the statement of the problem on the upper left-hand side. So I'm defining everything step by step. So X is measure of one person's IQ. The reason that I'm focusing on the word individual, one person, because in this section, we are finding probability regarding one person or one item. But in the next section, we are finding probability related to a group of people or a group of items. So you have to focus. If I want you to find probability of one person or for probability for a group of people. So X is measure of one person's IQ. Mu is 100, sigma 15. Okay. And I already told you that the IQ are normally distributed. It means they have a bell-shaped curve. To draw a bell-shaped curve, I'm going to go from the mu, which is the center on my curve, one standard. From the mu, I go one standard deviation to the right. I get 100 plus 1 times 15, 115. Then from 115, I go another standard deviation to the right. Another word, I can add 15 to 115, I get 130, which is mu plus 2 standard deviation, 130. Then if I add 15 to 130, I get 145, which is from the mu, I went 3 standard deviation to the left. Then I go 1 2 and 3 to the right. Then I go 1, 2, 3 to the left, minus sign. So from the center mu, which is 100, I go 1 standard deviation to the left, 100 minus 1 sigma, 85. Then I take away 15. From 85, I get 70. Take away 15, I get 55. So basically, from the mean center, I went 1 standard deviation to the right, 2 to the right, 3 to the right. Then from the center, I went 1 standard deviation to the left, 2 to the left, 3 to the left. So I locate these numbers and 100 in my number line here. 100 mu exactly in the middle. I went 1 to the right, 2 to the right, 3 to the right. Basically, the length of each tick mark on my x-axis is 15 units, standard deviation. Then I go to the left, 15 units. 100 minus 15, 85. 85 minus 15, 70. 70 minus 15, 55. The middle has the highest point. I put a dot. I draw a vertical line and I put a dot on the top of that vertical line. Then 1 standard deviation to the right and 1 standard deviation to the left have the same height. Put the dot on top of those vertical line. 2 to the left, 2 to the right, 2 standard deviation to the right, 2 standard deviation to the left have the same height. Put a dot above the lines. 3 standard deviation to the right, 3 standard deviation to the left have the same height. This height is arbitrary as long as the middle line is the highest, then you go exactly the same height with 1 standard deviation, same height with 2 standard deviation, same height with 3 standard deviation. Then I draw a bell-shaped curve through these dots. And I erase the vertical lines. If you don't want to erase the vertical lines, that's fine. Draw a bell-shaped curve through these dots and go to positive infinity. The same thing on the left. So that is your X curve. Okay. Any question about this graph? Okay. Then part B says, what is the probability that an individual is potential genius? We said that if a person has 136 or higher is potential genius. Like this is 130 line, correct? 136 is somewhere around here. Okay, somewhere around here. Exactly where I don't know, but the distance between each tick mark is 15. So 6 is a little bit less than half. So somewhere around here. So if I draw line 136 here, if anybody has a IQ 136 or higher to the right is potential genius. So I want to find the area of that region. Let me go to next slide. I'm finding probability of X greater than or equal to 136. Somebody, remember, X is one person's IQ. So if a person's have an IQ 136 and higher is potential genius. This is the graph of X curve. 136 is here. I want to find the area of this yellow region. In 6.5, I show you how to find the area of the Z, not X. So you're going to change this X to the Z by formula Z equal to X minus mu over sigma. So I'm going to change probability of X greater than or equal to 136 to probability of Z. So Z is X minus mu over sigma. X is 136 minus mu is 100. Sigma was 15. I just entered this expression exactly the way you see it. Parenthesis 136 minus 100, close the parenthesis, divided by 15. Round your Z to 2 decimal places, 2.40. So probability of x greater than or equal 136 is the same as probability of z greater than or equal to 2.40. Let me draw the z curve. This is the area of the shaded region, z curve. This is x curve with mu of itself, standard deviation. This is z curve. The z has always mu of 0, sigma of 1. You see that the area of the, so the area of x greater than or equal 136 is the same as the area of z greater than or equal 2.40. Look, shaded, yellow shaded region, mustard shaded region. They're exactly the same. So area under this curve is normal CDF of left side of the region and right side of the region.
Just to clarify,
Yes.
the z-score is not the area. It's written underneath it here, but the z-score is not the area. The area is going to be the result of your calculation of the normal CDF down here.
Z,
The Z is how far away from the middle you are.
yeah, the Z are, if you have one Z, is one side of your region, is one of the wall. If you have one Z, one side of the region, the other side is infinity. So Z always the bound of your region, bounds the Z. If you have two Z's, you have two bounds, left and right. If you have one Z, is either left and right. Here is the left bound, Z is the bound. Normal CDF gives you the area under the region.
The only reason I brought it up is it says probability of Z greater than equal to 2.4, and then underneath it, it says area. So I just wanted to make that clear that
No, probability of Z or X is always area of the shaded
it's
region.
the area. So it's the
Yeah,
probability,
probability
not the
of
Z-score.
either form is the area of shaded region, either yellow region or mustard region. They're exactly the same size.
Okay.
Okay.
And just as long, and now we're going to calculate that.
So I went to my calculator, I went to distribution, I picked normal CDF, lower Z was 2.40, upper Z E99, it gave me 0.0082, so 0.82%. When you are finding probability, you have to change the decimal for sure to percent. Any question?
Not seeing any in the chat right now.
Okay, let's look at one more
Okay.
example. The average age of CEOs is 56 years. So this is your mu. Do you see that I have been highlighting these problems? I highlight the key phrases. Average means mu. Mu is 56. Assume variable is normally distributed. It means my variable is continuous. It has bell curve. The standard deviation is 4 years. Sigma is 4. Okay. Find the probability that the age of one, again, randomly selected CEO will be in the following range: between 53 and 59 years old. So we want to find what is the probability that the age of one CEO is between 53 years old and 59 years old. Part B, between 58 and 63. I'm going to only go over part A. Part B is similar. In this example, I didn't ask you to draw the bell-shaped curve, okay? So that's the statement of the problem, upper left-hand corner. X would be age of one CEO. Again, one CEO. What is mu? X is normally distributed. It means You have a bell curve. These are giving you hints what to do. Mu is 56, sigma is 4. You want to find probability that age of one CEO between 53 and 59. You write, how do you write this between 53 and 59? You put variable X in the middle. You put two less than sign, only less than sign. You put the smaller number on the left, larger number on the right, okay? So this reads probability of X between 53 and 59. What is that? Okay, we have to find Z for each X. We have two X value, 53 and 59. We have to find two Z values. That is, when X is 53, this is the Z formula that you use, Z score formula. Z equal to X minus mu over sigma, parentheses, X is 53 minus 56, close the parentheses, divide by 4, you get negative 0.75. Then when X is 59, Z equal to parentheses, 59 minus 56 mu over sigma 4, it gives you positive 0.75. So probability of X between 53 and 59 is equal to probability of Z between, again, I write Z, I write P for probability, I open parentheses, I put Z in the middle, I put two less than sign around Z, less than sign, the tail is toward the left side. I put the smaller number on the left, larger number on the right. How do you find probability of Z between negative 0.75, negative positive 0.75? What does that mean? You are finding the area under Z curve between these two numbers. Here is the graph. This is my Z curve. The line in the middle of the Z curve is 0 line or mu line. Negative 0.75. Positive 0.75, I have to find the area of this shaded region, which gives me the probability. So I say normal CDF of the left side of my shaded region, negative 0.75, comma, the right side. And that is 0.5467. I change it to percent. Okay, any question? If you are on campus and you have a class at 1 o'clock, you can leave. My meeting, I set my meeting till 1 o'clock. If you have to leave, you can leave right now. If you don't have to leave, we're gonna stay till 1. Okay. Part B is exactly the same, but part B, one of them, both Z's became positive. I had to do the same thing. And example 3 is similar to example 2, so I'm not going to look at it. Sometimes you have to do the opposite. We give you the probability, you have to find the Z. And this is the inverse norm that we use. Like what is the 90th percentile for the weight of a 1-year-old boy and so forth. What IQ score is below 80% of all IQ scores. So I give you the percentage like 80%, and I want you to give me the Z that correspond to 80% or the X correspond to 80%. So I know I'm going over this quickly. I'm just going to go over it quickly. Then I will go back to these questions of this lesson next week. And if I have to look at more example, I will do. Weights of 1-year-old boy are approximately normally distributed. Okay. So X is the weight of 1-year-old boys, X. It is normally distributed. It means continuous. Why? Because to find the weight of something, you have to use measuring devices. Mu is mean, which is mu 22.8, standard deviation sigma 2.15. What weight does a 1-year-old boy need to have so that only 5% of 1-year-old boys weigh more than he does? So we want to find X where only 5% of 1-year-old boy weigh more than he does. B, what is the weight of a 1-year-old boy so that he is on the 85th percentile? So for part A and B, we have to find the X, which is weight of a 1-year-old boy. Part B, we want to see what is the weight if the boy is at the 85th percentile. For A, what is the weight, X, where only 5% weigh more than he does? Again, the statement of the problem is here. So X is the weight of 1-year-old boy. It is normally distributed. It has bell-shaped curve. Mu is 22.8 pounds, sigma 2.158. Step 1, when you are doing the opposite, when you are finding the X, every problem has 2 steps. Part A, step 1, we want to find the Z. You have to find Z related to X using inverse norm. Okay. When we say, let me move this a little bit so I can read the whole problem. What weight does a 1-year-old boy need to have so that only 5% of 1-year-old boy weigh more than he does? Okay, if only 5% of the boy have weight more than he does, we are looking at the right tail to be 5%. Okay? We have to find the Z using inverse norm formula. This is the graph. Only 5% of boy they weigh more than he does. So the right tail is only 5%. I want to find this Z value, this line. What is the value of this red line? First, I have to find the Z, then I find the X. So like the previous section, I say the area of the right region on the left side, the area of the right region plus the area of the yellow region is equal to 1. I need the area of the right region because inverse norm is area from -infinity to the Z line. So I need the area of this right region. So area of the right region plus the area of yellow region is 1. So the area of the right region is 1 minus the area of yellow region. Okay, the area of this to the left of X or white region is 1 minus the area of the yellow region, 1 minus 0.05, 0.95. So Z is inverse norm of 0.95. So area of white region is 0.95 plus 0.05 is 1. So in Z is inverse norm of 1.64. So I found the Z. Now I have to find the X. So I use another Z formula. First, I use Z inverse norm. Then I use Z score formula. I say Z is equal to X minus mu over sigma. Z was 1.65 from the previous slide. X, I don't know what it is. Mu 22.8, sigma 1.25. 2.15. Like the values, X is unknown. I put 1 under 1.64 and I cross multiply. X minus 22.8 is 1.64 times 2.15. X minus 22.8, the product is 3.52. Then I add 22.8 to both sides. I get X equal to 26.326. So what is the weight of a 1-year-old boy where only 5% weigh more than he does? Approximately 26 pounds. So when we are doing reverse problem, when we are finding X, we have 2 steps. The first step, you use Z equal to inverse norm. The second step, you use Z score. These are what we know from before. Part B, what is the weight of a 1-year-old? So he is at the 85th percentile. When somebody is at the 85th percentile, means 85% of the boys are way less than he does. Only 15% weigh more than he does. If you are located at 85th percentile, means the area to the left is 85%. To the left of X or Z line, 85%. So what is the area to the right? I really don't need the area to the right, but only 15% are to the right. Z is inverse norm area from negative infinity to Z line. I already have my 85%. So Z is inverse norm of 0.85, 1.04. So we found the Z first using inverse norm. Every time you want to find Z, you use inverse norm. Second step, you use Z score formula to find X. Z was 1.04, X is unknown, mu 22.8, sigma 2.15. I'm going to put 1 under 1.04, cross multiply. X minus 22.8 equal to 1.04 times 2.15. X minus 22.8, the product is 2.36. 2.236. I add 22.8 to both sides. I get 25.036. So if the weight of a 1-year-old boy is approximately 25 pounds, he is going to be at the 85th percentile. Okay, I went over this section quickly, but I hope you got the idea of finding probability of a continuous variable or normally distributed variable, probability of X between 2 numbers or larger than number or less than a number. You have to find the area under the bell-shaped curve. If you have to do reverse, you have to find X value, like this example. To find the X value, you have to find the Z value. You use first inverse norm formula, Z equal to inverse norm, then you use Z score formula. Z score formula gives you the X. I know I went quickly over this, but you still have time after your quiz tomorrow to go over section 6.2. Please go over 6.2 carefully after your quiz, because when you come to class next time, I really want you to completely gone over this section. If you have any question, contact Shauna or me. We can help you, because I like to look at other sections of this chapter. If you understand 6.2, then understanding the other section of this chapter is very similar to 6.2. Okay, very, very similar, except the Z, which is X minus mu over sigma, is going to be different. And all the formula are in your formula sheet. Okay, any question?
Not seeing any in the chat.